My name is Harminder, and today we're gonna cover left view of a tree. This question is easy to medium level, but this has been asked in multiple interviews, including Flipkart and Microsoft. So I'm gonna cover how this question was asked and how they changed this question in order to, understand that you have core knowledge of trees. So let's get started. Okay, let's understand the question first. The question was given a tree, initially binary. So given a binary tree, you have to let us know what is the left view. When we say left view, that means if you see this tree from the left side, how would it look like? So the only output would be 1, 5, 9, and 2. Why? Because 5 is hiding 7. So 7 should not be in the output. Similarly, 8 is getting hidden by the 9. 2, it doesn't have any other element, so that's why 2. So the output would be 1, 5, 9, 2. Now that is the question. What is the trick to solve this question is to understand that the left view would always be equivalent to the first node in the level order traversal. So if we know level order traversal, you already know that how to get the first node. So one way of solving this question would be that we would have a level identifier that we always add a null at the end of one level. So the first level ends at here, so we'll add null here. Second level ends at here, so we'll add null here. Similarly, null here and here. So whenever you are adding a null, that means it is end of first level. So what you're going to print? You're going to print the start of the next level. So that means when you are at null, you're going to print what is the starting point of the queue. When you are at this null, you're going to print this 9. Why? Because at the start of the queue, 9 would be there. When you reached at this null, 2 would be what you will be printing. So that is the one basic approach. If I explain you this approaches, you will create one queue, you will add the root element and null because that is the starting point. So once you have added that, then you will keep on iterating on that queue while all the elements are not exhausted in that queue. If you are getting null, you have to print the right next element. That would be your left view. So that is one. Now this question got changed when interviewer asked me. So how this question was changed is he want me not to use null identifier. That means you cannot use this null at all. That means you cannot have that identifier where you know that this level has ended. So if this kind of constraint he has put on the question, our solution needs to be changed. So instead of knowing how to end a level, you have to know how many elements there are in the level. So for example, in the first level, there would only be one element. In the second, there can be 4 at max, but we don't know. Oh, sorry, in the second level, there would be only 2. Similarly, the next level, it would be 4, and this, going forward, it would be 8 and 16. But there is no way of knowing for sure that what are the current level. How to solve this question now? This question can also be solved by taking into consideration how many nodes there are in the current queue. I'm gonna take this example. For example, let me create this queue here. So first I'm gonna push 1. Then I will say, okay, while queue is not empty. So here's our while loop. While queue is not empty, what I'm gonna do is I'm gonna check the current size. So what is the current size right now is 1. That is correct. So 1 we will get, and because this is the first element, we'll also print the left view of it. And then we're gonna check left and right. If left and right exist, we'll add that into the queue. 5, 9. Now the next time when while loop runs, it is again not empty. The current size got updated to the now size. Now size is 2. So what is the current size? That becomes 2. That is again the how many elements are at level 1. And then we will pop out 5. We will add its children. So 9 and 9 will be added. We will pop out 7 and we will also add 8. At this point, again, we will check while the queue is not empty, the current size we're going to update. So what we are doing, we are writing two things. One, while queue is not empty. Second thing we are doing is we are iterating for I is equals to 0, I less than current size. That means we are iterating over the current size of the queue because the current size shows us how many elements there are in the queue. So based on this approach, we're going to write a code and then let's see what interviewer has to ask again. So let me just write a code for you here. Yes. So you will be given basic definition of tree node. You can see left and right, and then the left view where you have to store the data in the vector. So here you will first create the vector where you have to store the data. So I'll write vector of int result, right? The second thing was creating that queue, because that is only gonna help us, getting into the level order traversal. So you'll write queue of node star and queue. Now you're gonna push obviously root, because that's where we start from. So we're gonna push root. Now I'm not pushing null because you're not allowed to use the null identifier. Again, I'm gonna write while not empty q dot empty. If q is not empty, what I will be doing is I will be checking the current size. So you'll write current size is equals to what is the current size of the queue. Right now we only added one root, so that's why current size would be 1. For each element, for int I is equals to 0, I less than current size, I plus plus. These are all the elements that are there in one level. In the previous example, we were seeing these are the elements at the one level. So at one point, 5 and 7 would be there, then 9 and 8 would be there, then 2 would be there, something like that. Now we're gonna say if I is equals to 0, that means what? That means the first node of the tree of that level, I is equals to 0, we were gonna push this into the result. So we're gonna push back I is equals to 0. Okay, let me just write it here. Tree node star, the node is equals to q dot front. So we will get the node, and also we will pop that node as well. So q dot pop, that is basic. So we're gonna push node data into the result. Now, if it is not equals to 0 or is equals to 0, we're gonna have to put all the children of this node into the queue. So in this case, you will write if it has left children. So if nodes left exist, you're gonna push q dot push nodes left. In case if node right children exist, you're gonna push right. Right. Yes. Moving on. Now, what you have to do is you have to keep on doing this till you exhausted the whole while loop. Once you have exhausted the whole while loop, your answer would be in the result. So this is how you do this question. So that is the first part of the question where we are saying, okay, in case you don't want us to use the null pointer, this is how we will solve the question. Now, the follow-up question the interviewer asks is, you are not given a binary tree, you are given an N-Ary tree. So this is the definition of binary tree. How would you change your existing code in order to understand that this could be more general or generic tree? So in that case, left and right would not be there, because left and right means only two children. It can be n children. So in that case, we have to write vector of tree node. So these all changes interview wants us to do. So node star children. So why I'm saying that? Because we don't know whether left or right exists, because they can be 2 children, 5 children, 10 children. So we have to store that data into the list or vector. If you're using Java, you can create a list. I'm using C++, that's why I'm writing a vector. So once you have that thing, what will you change in this code? Obviously, your root will be same. Your size would be same. This tree node also would be same. When you are pushing left and right, now you don't have left and right. What do you have? You have children. So instead of these left and right, now you have to write the for loop. For int children is equals to 0, children less than that of the current node's children. So you'll write children dot size. So what I'm doing is this current node, how many children this current node has, I'm getting its size and I'm getting one loop over that. So child plus plus, right? Now in this case, instead of pushing instead of pushing only left and right, we're going to push all these children. So we'll write, okay, now q dot push would be happening on node nodes children. And what children we are talking about? This child here. So nodes children would have a vector, and that particular child we're gonna push. So we will push that. That also we also have to see, right? Uh, yeah, so this is how you will change the code. So that was asked in an interview, and this is how I solved it. Again, time complexity and space complexity we can discuss. Time complexity will be order of n, where n are the nodes of a tree, and space complexity wise also we are using space as a queue. So it would be how much space we are using it at one level, how many maximum children it has. So if one level has 16 nodes, the maximum complexity would be that. I hope you have understood this problem and how to respond this, where interviewer is asking you these kind of questions. Thank you for watching the video.